All right. My name is Ron Pressler. I work at Oracle in the Java Platform Group, and I'm here today to talk about Java. So first, everything I'm going to talk about are future plans, not promises. So Java has grown very big, and it's growing fast. And the landscape in which it operates is quickly changing. We see new kinds of deployment, public cloud, private cloud, hybrid, new kinds of devices, new kinds of services with real-time transactions, more interaction. And Java is going to need to grow and adapt to the changing landscape. To do that, we want to ensure that Java is well-positioned for this present and future. And here's how we plan to do it. So Java has been open for quite some time, but we are going to make it even more open, as you'll see. It's constantly evolving. We have to adapt to new development paradigms, new deployment paradigms. And in general, adding stuff is easy. Changing existing stuff is harder. And removing things is much, much harder, sometimes impossible. And we have to be more nimble in our approach. We feel that the pace of change in Java over the past 2 decades may have been a bit too slow. We're changing that. And of course, we need to continue to scale both with the demands of growing applications and with a growing community and ecosystem. So these are the things we're investing in. First of all, security is a top priority. We aim to fix exploits as soon as we find them, but also to make the platform more resilient to vulnerabilities. We want to improve developer productivity and interoperability with native libraries and native code and stuff like containers. We want to increase and improve Java's performance, its data density, the two are closely related, reduce startup times, improve the predictability of things like garbage collection, and improve our ways of monitoring and profiling applications. So last year, we promised to make a big change in the way Java evolves, and this change is already in progress and has already started. Our previous release model, at least the way it was supposed to be, was that we would have a major release every 2 years. Each of those releases would be maintained and supported for about 11 years. But in fact, if we zoom in, we see that actually we had releases about every 6 months, update releases. So we've had the ability to push out versions about every 6 months. But those releases were update releases. Okay, so we had Java 8 and then update 20, 40, 60. Those names may have been unfortunate. And usually, every major release had about 3 updates 6 months apart. Of course, the reality was a bit different because the major releases were mostly built around 1 or 2 major features. And until those features were ready, we couldn't deliver. So they were pushed a bit. And in practice, the time period between 2 major releases was closer to 3 years. And if we were to continue this model, then in Java 9 we would have 9 and then those update releases. But update releases are limited by the JCP rules. We were limited in the things we could change in them. We could not make language changes. We could not add new APIs. And this is something that we wanted to change. So now we have what we call a feature release every 6 months. Those feature releases look like this. We just call them 9, 10, 11, and so on. And those releases are not limited by the changes we can make in them. In each of them, we can make language changes, we can make API changes, and they're going to come out every 6 months. The first, Java 10, is already out, the first in this new model. But what about support? So before, I said every major release was supported for 11 years. And in fact, it wasn't truly the major release, it was the latest update release. Obviously, we cannot support so many releases at the same time, otherwise we'd have the stack would just be too deep. So we borrowed an idea from other projects, and some of those releases would be called LTS releases, long-term support, and they would be similarly supported for many years. How long would it be between each of those releases? So I said that in practice, the time period between major releases used to be 3 years, so we're keeping that the same, and it's going to be 3 years between LTS releases. Yes, so it's supposed to be 17 there. So the first LTS release would be 11, which should come out this September, and the next one will be 17 in 2021. Of course, we're not changing the model for the old versions, so 6, 7, 8 would continue to be supported according to the old promises. Java 8 in particular is expected to be supported for a long while yet, at least until 2025. Now, what about licenses? So, up until now, the way Java was developed to Oracle is that we worked on OpenJDK, and then the binaries we delivered were actually not builds of OpenJDK, but we took them, added some commercial features, and released those under the name Oracle JDK, before that Sun JDK. And they were released under a binary license, so of course the old versions of Java would continue to be under that license. But we are now open sourcing all of those commercial features, and they're all going to become part of OpenJDK, and so Oracle JDK and OpenJDK are going to be identical, exactly the same. OpenJDK would continue to be released under the existing GPL license, GPL plus class path exception, and the long-term support releases would be under the Oracle OTN license. Another way to look at it is like this. So we have a train of releases of OpenJDK coming out every 6 months, and once every 3 years, an Oracle JDK with long-term support will come along. Now, most developers would want to keep up with the OpenJDK. Large enterprises would likely want to deploy to production and the long-term support releases. However, even if you choose to deploy to production on the LTS releases, we strongly encourage you to keep up with the feature releases every 6 months, and this way, when the new LTS comes along, you'll be almost ready. In terms of features, the LTS releases are exactly the same. It's not they're going to have more features. They're still almost arbitrarily chosen feature releases would be deemed LTS releases. In addition, the binaries we deploy and deliver will no longer be Oracle JDK, but you'd be able to download. We will now build OpenJDK binaries, which will be the ones that you'll download and use. Now, I mentioned before that we're open sourcing all of the commercial features that used to be part of the Oracle JDK and moving them to the OpenJDK. These are those features. The first is application class data sharing. It helps reduce startup time. Two very interesting ones I'm going to talk about a little bit length is flight recorder and mission control. They help with monitoring and serviceability and profiling. And the usage logger is helps an enterprise manage its JRE's installations, which machines are running which versions, etc. So who here is already using Java Flight Recorder? Okay, if you're not yet, it is truly amazing. It is a monitoring and profiling tool. It is designed to work in production, not in development. You record your running application. It has a very low overhead, and it gives you a very, very detailed analysis of everything that's going on inside the JVM. Performance of code, garbage collections, object allocations, etc. And you don't need to modify your application in any way to work with this. It works with any Java application, and it has very low overhead. So if you're familiar with various profilers, they have a few problems. One is that they're not very precise, and the other is that they introduce a very large overhead. They're intended for use in development time. That you cannot run them on production code. Java Flight Recorder is intended to run production code. Your application is running occasionally. You start a recording, record for a few minutes or hours, then you take the recording and analyze it in mission control. Okay, so Java 9 was a transformational release with over 150 new features. Most important among them was Project Jigsaw, the module system. And this is the keystone that will allow us to move forward faster with a release every 6 months. So it was released in September of last year. These are some of the features that were included, many of them. And I mentioned Project Jigsaw. The primary goals of this project were, one, to make it easier for developers to build and maintain libraries and large applications by modularizing them, improve the security and maintainability of the platform itself, improve performance and security, and allow the platform to scale down to small devices or very dense cloud deployments. So before, we had a monolithic runtime library, and we've broken it down into a graph of modules and dependencies. And if you now have an application, you can choose to modularize it, and you can say my application depends on those two JDK modules. Of course, this dependency is transitive, so it depends on all the modules those depend on. But with the JLink tool, you have the option of creating a custom runtime for your application only, which includes the JVM and only those modules of the JDK that your application actually uses. So an application like this could be as small as 40 megabytes instead of hundreds of megabytes. Now, Project Jigsaw improves security because, first of all, it encapsulates every module has a well-defined external API and internal classes that cannot be accessed by external modules, other modules, even with reflection. They're completely hidden. So this improves maintainability because if you're writing a library or some module in your big application, you can be certain that all those clients, whether be they in other companies or in your own company, will have no access to those classes that you choose not to expose. And this way you can be certain that they have no dependency on the internal implementation details of your module, and you're free to change them. This also improves security because, as I've shown you before, you can create a custom runtime that includes only those modules that you actually depend on. And so if there are vulnerabilities in modules that you're not using, which would normally be the majority of them, you're just not exposed. So it reduces the attack surface. Another thing introduced in Java 9 was ahead-of-time compilation. So the way the hotspot JVM, that's the JVM of the OpenJDK, the Oracle JDK, the way it works is that you first compile your Java code to Java bytecode. and then the JVM first starts interpreting the bytecode. It collects profile measurements of how it runs, and then it compiles them into native code, only those methods that are very hot. So this emits very, very efficient code. This is one of the perhaps one of the best compilers in the world. However, because it runs at runtime, it takes a while to warm up. It has to collect the measurements first, run them through the interpreter, and then it has to compile them. You now have the option of choosing to do a part of this process ahead of time and compile them to native code, preferably on the machine you're going to run your code, because the code the compiler emits depends on the capabilities of the machine, but you can do it before runtime, and those would be compiled into ordinary native libraries. Now, two things. You would still need the JVM for this, and currently, this only works for the JDK classes itself. You cannot yet compile your own application ahead of time, just the JDK classes, but often it's quite long. And so it greatly reduces startup time. It may or may not have some adverse effects on the code, because at this time the code is not optimized exactly for the way your application works, but you should just try and see. Another nice feature is JShell. That's a REPL. You can program and experiment with Java interactively. I know, personally, I'm not used to programming with the REPL, but I know many programmers are, and they really like it. So if you like REPLs, and if you don't, you should try, and if you like them, this would be a great addition. G1, the new garbage collector that's been delivered along a while ago, it is optimized for a better trade-off of throughput and latency, is now the default. So if you launch Java application and do not explicitly specify garbage collector, G1 starting with Java 9 is the one that will be used. Of course, many more features, and if you want to learn about them in more depth, you can watch the screencasts. Either go to this URL or just search for them. Okay. Now, Java 10 has arrived, which is the first release in our new, this is the first feature release. Unlike Java 9, which had over 100 or 150 new features, this one has only 12. And that is not because something has slowed down, but simply because the goal of the change in the release model is not to increase the throughput of changes to Java, just to reduce the latency. Features are released whenever they're ready. And this means that if before transitioning from one release to the next, to a major one, may have taken a while, the delta between two consecutive feature releases will be quite small. So keeping up with this fast pace, after you've made the transition to Java 9, which may be painful at first, but after you've done that, the delta between consecutive feature releases would be quite small, and this is the order of number of enhancements that we anticipate going forward. Some things available today in Java 10. So if you go to download Java wherever you download from, Java 10 is, JK 10 is the one you download. One very public change is a change to the language, local variable type inference. So we used to define variables like this. We had to declare the type, then name the variable, and then instantiate them. Instead, today, you have the option of not naming the type, just using the keyword var. The variables are still typed, it's just that you don't have to type it in. The compiler infers them for you, because the compiler can tell their type from the value you assign to them. Also available in OpenJDK 10 is application class data sharing. This is the first commercial feature that has made its way into OpenJDK. This extends the class data sharing feature from being just for JDK classes to even the application classes. It allows sharing some metadata among different applications, different JVM instances running on the same machine. It generally reduces footprint and startup time. There is something about root certificates. I have to admit I know nothing about security, but if it means something to some of you, then good. Okay. One very exciting project we're working on is project ZGC. This is a new garbage collector optimized specifically for low latencies. It's supposed to, the pause time, the maximal pause time does not depend on the size of the heap. It supports multi-terabyte heaps. The maximal guaranteed pause time is 10 milliseconds. From what I hear in practice, it's usually far less than that. And as usual, there's a trade-off between throughput and latency. It says that it reduces throughput by no more than 15%. Again, from what I hear, it usually does better. It used to be, it was intended to be a commercial feature, but it has since been open sourced. And while not yet available as part of a public availability release, you can already try it through one of our early access releases. Okay, what's next? So next, September this year, Java 11. So at first, we believed that 4 enhancements, 4 JEPs, would make it, like I said. We no longer wait for features to be ready. We make a release. We cut a release every 6 months. Whatever features are ready, they go in. But since then, more features have become ready, and now the list contains 8 enhancements. Beyond that, perhaps the biggest challenge yet is the object data layout. Java is very good at emitting very optimized code, but it is not as good at optimizing data. This has several effects. First, it means much increased RAM overhead. And also, the way modern hardware works, this is, I believe, perhaps the last bottleneck separating Java performance from languages like C. So we are changing that. In terms of expressivity of the language, we have everything we need to define any kind of data structure, but we don't have the control we need. The primitives are fixed. We only have 7 of them, I think. And objects are very, very flexible, but they have a cost. They have some features that we don't always need. So every object today has an identity. Like it has a reference. It's used with a pointer. And this is needed for stuff like ad hoc polymorphism, inheritance, etc. It's needed for synchronization if you synchronize Java monitors. But not all objects need it, especially objects that just contain a bit of data. And they're not mutable, and they're not shared, but still they all pay for it. Project Valhalla is going to add what we call value types. So value types are programmed like a class, but they create something that looks like, that behaves like new primitives in the language. So if you have an array of value types, instead of the array containing pointers or references to those objects would actually be embedded in the array, thus reducing both RAM overhead and access to those objects. It actually has a big impact on performance. Basically, they behave like C structs. Another thing we're working on is that some very important projects depend on native libraries, especially math libraries, that are native. And currently, the way to interoperate Java and native code was through JNI, and if you tried it, you know, it can be quite tedious. You need to write C code. It can crash if you're not careful. So Project Panama will have a new foreign function interface that will allow you to interface with any native library without writing any C code. It would have the performance would be at least as good as that of JNI, but it would be safe, and you'd automatically have a way to call those. Those libraries would be exposed to you as Java libraries. You may need to define how they're used if the definition is not available, but you won't need to write any C code. Finally, Project Loom, the project I'm leading, would add lightweight threads to the JVM, the goal is to be able to spawn millions of threads at very little cost. Another important feature is Project Amber. It continuously adds improvements to the Java language, like local variable type inference. It's going to change the way you're able to write string literals, so you very easily be able to write multi-line literals. We're adding something called pattern matching, if you're familiar with that from functional languages. So this is coming to Java. So, to summarize the key points, development of Java is becoming more open. OpenJDK and Oracle JDK would become identical, and we're contributing to open source all of the previous commercial features. They would be released under the existing OpenJDK license. The fast pace of change in the industry requires a faster pace of change in Java, and we're going to cut a new feature release every 6 months. And we have some very exciting and big and important changes we're working on beyond Java 10. How much time do you have? All right. So I'll take some questions now, and then if we have some time, I want to talk about in more depth about Project Loom. Questions so far? Yes. Yeah. So, or as far as I know, I'm not sure because I work in my small part. I think in terms of the platforms that Oracle developers are supporting. Oracle, I think, is not supporting 32-bit architectures and ARM, but other people working on OpenJDK are. I think Red Hat has support for ARM, but yes, at the moment, it's Oracle. We're not developing support for those architectures. Yes? Questions? GraalVM, there are people from the Graal team here, perhaps better oriented, but it's not entirely separate. I think starting with Java 9, you were able to use Graal as an alternative compiler to, in Hotspot, the optimizer compiler is called C2. Now in Hotspot, you can use Graal compiler instead of C2, starting with Java 9, and this is something that you should definitely try. I know Twitter has seen improvements with that. But you no longer need a special build of the JDK starting with 9. You can just use an ordinary Hotspot parser flag and use Graal instead of C2 as the optimizer compiler. Graal also has compilation to native methods of your applications, some subset of Java, but you should talk to the Graal team about that. Yes? Is there a guess as to when Valhalla will be out? When it's ready, but it's coming along nicely, I can say. Did you have a guess? No. And if I did, I probably wasn't allowed to say it, but I don't. All right, yeah. So Oracle JDK is the one that Oracle is going to provide paid support for. So if you want support from Oracle, you'll buy a license for Oracle JDK. They're the same in terms of code, but of course, if there are security patches, OpenJDK, at least Oracle developers in OpenJDK would only make those fixes on the most recent current version, and they would be backported only to the LTS versions. Okay, so now, oh, yes?
As you expand the language, is there any evidence that people are getting worse at it?
That's a very good question. The question is, as the language grows, is there any evidence that people are getting worse? Is that what you asked? Yeah, that is a very good question, and one that I think somebody should research, but I don't have the answer for it. All right, so let me say a few things about Project Loom. So Project Loom adds continuations and fibers. I'm only going to talk about fibers and also tail calls to the JVM. So fiber is a thread, but one that is not scheduled by the operating system, but by the Java runtime. So some call it lightweight thread or user mode thread, And it works the same way, but you can have millions of them because they have very low overhead. Low overhead in terms of RAM and low overhead in terms of task switching costs. The reason we want to do it now is that sessions between clients and the servers are getting longer, which means that servers experience more concurrent open connections. And in practice, what we see that many applications, I think those are numbers not from Java applications necessarily, many applications that work in the old programming model are severely underutilized. They don't utilize the hardware. Modern hardware can support over 1 million OpenTCP connections, but it cannot support 1 million threads, not even 0.1% of that, barely. And so today, developers have a choice between writing code, let's call it the old way, of blocking code, let's say 1 per application unit of concurrency, say 1 per request or 1 per session, 1 per user, etc. But in that case, they're restricted by the number of threads that the application, that the operating system kernel can support. And like I said, that number's in the low thousands, even though the hardware can support a much larger number of OpenTCP connections. The other alternatives is to write code a new way, non-blocking asynchronous code, but this means that it's very hard to port legacy code to it. It's much harder to debug, almost impossible to profile well, but it's scalable. So fibers are intended to remove this trade-off and to let you have it both. The performance and scalability of asynchronous code, but the simple code, easy debugging, easy profiling of old blocking code. From the perspective of the developer, you just spawn a thread, write ordinary blocking code, but you'd be able to have millions of those. From the perspective of the operating system and the hardware, the operating system would feel as if you were writing asynchronous code. So it's like we're making this transformation from blocking code to asynchronous interaction with the operating system automatically. And of course, this allows you to pack more stuff on a single machine and increases utilization. So this is what we want. Remove this choice between easy, nice, maintainable, debuggable code and performance, and to allow people to use the hardware more. So the idea is that the language runtime is better positioned to manage your threads than the operating system. The operating system has to be very general. It has to take into account many different kinds of threads, threads that handle transactions. So they work for a little bit and then block an IO, say, or on message from another thread. And threads of a completely different kind that do that play video. So they behave very differently. They also can't assume anything about the languages you're using, so they should support every language. As a result, threads incur very large overhead, both in terms of RAM and in terms of performance. And of course, you have to go to the kernel, switch to the kernel every time you switch between 2 threads. Now, we're not entirely sure how this is going to look like, but we think that fibers are going to appear like an ordinary thread from Java. You pass a runnable like today, and you'd optionally be able to pass it a scheduler. We're going to use schedulers written in Java to schedule those threads. Another alternative is perhaps have some abstraction that would abstract both thread and fiber. But we're leaning more towards the first. And the idea is that you will be able to write, so this says fiber, it might be thread, we haven't defined an API yet. You'll be able to write ordinary blocking code. This is an example of an HTTP server. So you'd have a single fiber that just loops around, accepting connection, and it spawns a new fiber for every incoming connection. And this would behave in terms of performance and RAM overhead exactly, or almost, like as if you'd written it in a non-blocking style. But your old code should work. If you want to do things in parallel, because fibers are so cheap, they're essentially free to create. You want to send 2 requests and wait for them. You just create a new thread, this lightweight thread, and block on them. Blocking is free, creating threads is free. all the existing libraries are supposed to, we hope, they should work unchanged. So servlet JAX-RS, you would just be able to configure your servlet container, let's say Jetty or Tomcat, and just say, please use lightweight threads instead of ordinary heavyweight threads. And they open the door to new kinds of programming paradigms like actors, data flow, channels like in Go. Let me show you an example. You'd be able to do stuff like create a channel and use, these are like blocking queues, but with some nice features added on top, and have fibers or ordinary threads communicate using them. Channels could perhaps, for now we're leaving this to third-party libraries. We just provide the fibers, but this is very easy to do once you have them. You'd be able to, those channels add some transformations like channel filters and maps, transforms some of the messages. And a very interesting feature we want to provide, I don't know if in the first release, but we will provide eventually, is serialization. The point here is that you'd be able to write code that would run the fiber or thread. You'd be able to pause yourself and then serialize to disk or to the network and continue this program from where you left off on another machine or at some other time. I think we'll stop here and take more questions about Loom. Yes? Yes, the control is by the scheduler. So you can use the default scheduler. It's probably going to be based on fork join pool because it's a very, very good scheduler that works really well with this kind of threads that do a bit of work and then block and then do another bit of work. But you can provide your own scheduler, and your own scheduler can say, I'm always going to put this fiber on this thread, on this kernel thread. This one, meant? Yeah, so the same API, all the Java IO libraries in the JDK are already adapted in the internal work we're doing right now to work well with fibers. So you'd use the same old APIs, but they will not block the underlying kernel thread. So to you, they would seem blocking the operating system so that it would appear as if it's asynchronous and the thread never blocks. One more? Okay, so thank you. Oh, yes.
What kind of improvement are you like to see, or are you probably a better way of asking that?
So again, you can look at the improvement from two directions. From the direction of performance, so if you used to write all blocking code, you'd have a huge change in performance, probably 10x at least. Or if you look at it from today, if you want to get this kind of performance, you need to write asynchronous code, which is harder to maintain, debug, etc., port to, then the improvement would be in ease of use, ease of monitoring, because this way you have it very cleanly attaches a context. So today, if you're using asynchronous tasks, you attach a context. If you have an exception, you have a stack trace. If you're using existing monitoring tools like Java Flight Recorder, it give you a context of which of your fibers are taking the time. This is information that is either gone when you use asynchronous code, or you need to use specialized tool for the specific asynchronous library you're using. So different ways of looking at it. Streams is more for, so fibers is more for reactive or interactive kind of things, handling transactions. Streams is more for batch processing of large amounts of data. So the two are complementary. They're not.
So where you currently run the stream in parallel, that we use run-line thread call,
Yeah.
you actually prefer to use fiber?
No, I don't. I think the assumption today, the Stream API would likely accommodate fibers in some interesting ways, but I think it largely assumes that the tasks you run in it are non-blocking. So if you're not blocking, it doesn't care. But today, if you accidentally or not use something that is blocking, you have to interact with a thread pool in some specific way. But if instead you do that plugin code in a fiber, you'd be able to use that as a stream task, job, whatever it's called, and to the scheduler would appear to never block, so it would make things easier and faster. All right, so thank you very much.